Hey everyone, my name is Brian and I'm the 3D print creator, and in this video I'm going to answer all of the questions that you asked me about laser engraving. And well, believe me, there were a lot of questions. So I think this is the full tutorial about laser engraving, but for safety reasons I call it part 1 because, well, maybe you have more questions after seeing this video, and well, maybe there will be a part 2. So let's get into it. Now, in this video we will talk about laser power and why this is a very important thing. How much power do you actually need to do the things you want to do? And well, what's the difference between an 8-bit laser engraver or a 32-bit laser engraver? Because the controller board really has a big influence in how good it will engrave. And I will show you later why this is. We will also talk about the light triangle, and the light triangle, well, that's something that you will need because the light triangle is the angle in which your beam will hit the material. And well, for different needs you will need different triangles, and I will show you how this works and why this is so important. Then also the difference between engraving and cutting. There is a huge difference in the settings you have to go and make between engraving and cutting. And I will explain why this is. And the last thing, but very, very important, the Beilstein test. If you don't want to die because you are using lasers, then for sure you have to know what the Beilstein test is. And I made a complete video about it, but I will link to that later in this video. Now, the first thing to know is the input power versus the actual light output. The most makers of diode laser machines, the most companies that make them, are not really telling you the real power output of the laser machine. Or sometimes they do, but it's hidden somewhere. So, for example, the lasers that I work with on my channel, they are 20 watt, 15 watt, that kind of power outage. But for real, they're not, because my 20 watt NAJ machine is actually only 5.5 watts in the laser output power. And the same goes for my Ortur Master lasers that I have, which are really 4.5 watt instead of the 15 watt that they claim to be. So the 15 watt or 20 watt that you see on the website when you're buying such a laser is actually only telling you how much power the complete machine consumes. And well, this means the motors, the controller, the other components in the machine, the heat that is generated, all those things well, are also calculated in the power that the machine consumes. But the real output power, the real power in which you can use it to cut or to engrave, is limited to most of the times a quarter or a third of the stated power. But then the question raises, how much power do you actually need? Well, this determines the kind of laser you are going to buy. And for example, there are multiple ways that determine the effect that your laser has on the material that you are going to use to engrave or to cut. There is the power of the laser, there is the travel speed of the laser, how many times you are going to repeatedly cross the same path, and the color or wavelength of the laser. Those are all influencing how effective the laser will be. So let's start with the power of the laser. Well, the more power you put into the laser, the more heat the laser will transfer into the object that you are engraving or cutting. Now, some objects that you are working with, they cannot be too hot or they will break or they will catch fire. Like, for example, if you're working with felt or paper, then it's very easy to make them catch fire. And therefore you need to lower your power to the power you actually need to write or cut on that material. Now, it's a good thing to test which heat, so which power you can use for your material before you kill your object. So before paper catches fire, like you saw in my last video where I engraved something in a glass. Then the paper in that glass was catching fire just because my power was just a little too high. Now, this is something you need to know, and you can set in your machine settings. Now, a second way to control the amount of heat that is generated on the material that you are engraving or cutting is the travel speed. The faster the laser goes, the less heat it will produce on the surface of the material that you are cutting or engraving. So if you need more heat, well, you need to go slower. And if you need more, if the material is catching fire, well, go faster, because this also determines how much power will be absorbed in the material that you are engraving or cutting. Now, the third thing that will determine if you can cut, for example, a thick piece of wood is how many times you are going to be repeating the steps over and over again. So if you are engraving a circle in a piece of wood, then the first time you will cut 2 millimeters deep. The second time you will add, well, maybe a millimeter to it. And the third time you will add maybe half a millimeter to it. But if this material was only 3 millimeters deep, then the first time you wouldn't have cut the complete circle out of that wooden board. But the second time, well, maybe you have, and maybe on some points you don't. And in the third time, well, you're completely through the material. Now, you will see that the more times you are going to repeatedly cut the same object, the less effect it has. And therefore, many repetitions, they rarely make sense. But I think 5 repetitions, something like that, that will make good sense, because everything more, well, it won't work, because there is a lot of charcoal there where you are laser engraving, and your laser will be out of focus, which we will talk about a little later in this video. And now the last thing is something you can't change, but you have to know it. The wavelength of most of the diode lasers that we are using and that we can buy on all the websites, this is 450 nanometers. And this means that it's kind of blue color. And well, it's a type of laser that can cut certain things, and certain things can't be cut with this laser. And you have to deal with it. So there is a bit of acceptance. You have to know what your laser will cut. So paper, leather, wood, dark acrylic. Such materials are very easy to cut or to engrave with a diode laser. But you won't be able to engrave stone or steel or the most types of glass. Well, you have seen in a previous video that I engraved some glass with my laser. But normally it will be very difficult to do so. Now, what's the real difference between engraving or cutting in materials? It's really important to know. When you want to engrave in things like in wood or in cardboard, most of the times people are engraving in wood, then you need a little less power than when you are cutting. You will need a lot less power than when you are cutting. And also you will need to dose the amount of power very, very much. And the better you can dose the power, the better your engraving will be. While if you are looking for a machine that can cut, for example, acrylic or paper or cardboard or wood or that kind of things, then you want a whole lot of power and you want to have it transferred in as much possible heat as you can between a certain timestamp. So the controlling speed and the laser power are then determining how deep you can cut in materials. But for engraving, you really want to dose a very, very small amount of power onto your material. And this is where 8-bit versus 32-bit controllers come in handy. Because A processor that works with an 8-bit way of calculating things can only control the laser in 255 steps. Now, for example, it's 256 of course, but 0 is laser is off. And therefore there are 255 definitions of how powerful the laser is. Now, when you have a 32-bit processor, then a 32-bit processor can do many more steps. Really way too much steps, but that processor will be way faster. So there are two things. The one thing is that you can't control your laser in more than 255 steps, and I will explain later what it does. And the second thing is that the processor is slowing down the complete machine if it's an 8-bit processor, because it can't cycle to the G-code that you are having for your laser that fast. In theory, a 32-bit processor would also be able to control the laser power in very small steps. Where an 8-bit processor can only subdivide the laser power into 255 steps, a 32-bit processor could make, well, I'm not going to, sorry, I'm not going to number that over there because it's a giant number and I don't know how to say it in English. But it's incredible. But this is completely unnecessary. Normally the lasers that have 32-bit processor boards, they are working with 1000 steps to increase or decrease the power of the laser. So they made it smaller than the processor could handle, but 1000 steps is 4 times as good as an 8-bit processor can produce. So therefore, if you are going to engrave things, well, an 8-bit processor is less good than a 32-bit processor because it has way more grayscales to engrave, for example, a picture. So when you are engraving things, then it requires a small cutting depth, so a very little power. Also, it requires a lot of nuances between the deep blacks and the color of the material that you are going to engrave. And therefore, for example, a 7-watt diode laser has only 1.75 watt of actual light output. Remember that I told you that about a quarter of the given power really is transferred into light. And therefore it's only 1.75 watt of actual light that you can use to engrave. Now, with an 8-bit laser machine, you can subdivide that 1.75 watts that you have in 255 gradations, and each of them will be 6.8 milliwatts big. So every time you go one step deeper with the grayscale, it's 6.8 milliwatts of more heat that is going to be transferred into your material. Now, if you have a 32-bit laser machine that does 1000 gradations of grayscales when working with the same laser tube or the same laser diode, it's a diode, not a tube, then it can subdivide that 1.75 watt into 1000 gradations, meaning that each gradation is only 1.75 milliwatts, and therefore it's 4 times as small. And well, you can imagine that you have a lot more grayscales, and therefore your black and white or grayscale prints will be a lot better when you have a 32-bit machine instead of an 8-bit machine. Now, the light triangle is a very important thing to know, because a light triangle is the light that comes from the diode laser, and on the top where it leaves the lens with which you focus the laser, the light is very big, it's very wide when it leaves the lens. And then it goes down, and it goes down to the point where you have focused the lens, and there it has a lot of power. Now let's take a look what what this power means. When you are having a good lens on your laser, and most of the times those lenses are pretty good, and sometimes you can even buy better lenses for them, a good lens can project a dot that has a radius of about 0.1 millimeter, and this means that the real object that you are heating up is 0.00785 square millimeters. So it's really small, and this is where all the heat that comes from the laser will be transferred into burning power for your laser to burn or cut. Now, if you don't set the focus right, and you have, for example, an object that is lit of about 1 square millimeter, then this is 10 times less powerful. So just being a little bit out of focus, too deep or too high, as you can see over there where is it? Here is it. A little bit too deep or a little bit too high with your focus really means a lot for the power of your laser. Now, this also means that if you are cutting, the first time you're on top of the material, you will cut very deep. But the second time you go over that same place, it won't cut that deep. And the reason is just, you're out of focus. And therefore, the power of the laser is decreasing rapidly. So there is a big difference between cutting and engraving. For engraving, you focus exactly on the surface of the material that you are going to engrave, and you use the minimum focus distance, as you can see in the first block over there. The first block there with the green heart, it shows you that the laser is very close to the object that you are going to engrave, and the focus point is exactly on top of that surface. While with the other two things you will see here, the other two drawings, you will see that the laser has too much space, and therefore it's cutting way deeper into the material, and you don't want it because you want to engrave. So it's cutting way deeper into the material, and therefore your cutting or your engraving won't be that nice. And with the third block, the block the most to the right, there you will see that you have your power way too deep into the material, and therefore you won't be engraving that nice because a lot of power is lost because the surface is way too big that you are lighting up. Now, when you are cutting, as you can see over here, then you need to focus in the middle of the material, and you need to be as far away as possible, so you need to have the maximum focusing distance from the material that you are cutting. And the reason is very simple. You have to go as deep as possible. Therefore, the first time you will cross the surface of the material, you won't be cutting that deep. But the second time you can cut way deeper because then your laser will be in focus. And therefore you can try multiple passes, and then 5 passes would be very good to be cutting real deep into the material. And I have reached about 5 millimeters with my 15 watt laser machines. Now I have to say that 5 millimeters was difficult. Sometimes I cut completely through it, sometimes I didn't cut completely through it. But 3 millimeters or 4 millimeters is very doable in normal wood, in plywood for example. I can cut 3 or 4 millimeters at ease when focusing at the correct point. So normally if I have to cut, for example, 4 millimeter plywood, I first use a 2 millimeter sheet of plywood. There I lay my focus, and after I focused, I put the 4 millimeter thick plywood plate underneath the laser, and then I know that I'm focusing at the center of that plate. Now again, as you can see, the farther away you are, the better it will be. And if you are focusing on the top layer of the surface, well, you won't get that deep cut. You will get a nice engraving, but not a cut. And if your laser is way too close to the material, as you can see here on the left, then the material will be cut, but it won't be that deep because the angle is way too shallow. And here you can see what happens when that angle is too shallow, because at the most left drawing, you can see that you can cut very deep, because even at the surface and also at the bottom when it's going through the material, it's still a shallow beam. While on the other one you see here on the right, there the beam is it's way more wide, and therefore a lot of power will be lost on the top of the surface of the material, but also on the bottom surface, and you won't get through it. Now, I already told you about the Beilstein test. I'm not going to tell you everything about it in this video, except that I made a video about it. And well, there is the cover of that video, but of course it will be linked up here, because it's a very important video. If you don't do the Beilstein test while cutting or engraving certain kind of plastics, then you're releasing very horrible fumes that can potentially kill you. So please be wise and know what the Beilstein test is. And if you don't know what kind of material you are working with, perform the Beilstein test. It's a very easy test. Go and see that video, and well, it's a very important thing to know. Now everyone, thanks for watching this video. I hope you learned a lot, and I hope you will make better engravings and better cuts with your laser engraver or laser machine that you have. If you don't have a laser machine, or maybe you are just willing to buy one after you have seen this video, there are a few links in the video description down below. And with those links, which are affiliate links, you are really helping this channel. So if you buy your laser through one of these links, you're really helping this channel. What also helps for this channel is if you like this video. It will tell the YouTube algorithms that this is a good video, and therefore they will show it to more people, and that really helps out the channel. Which also works if you subscribe to the channel, because, well, about 80% of my viewers, I think, is not subscribed to the channel. So please go and do so, because I will make a lot more of content about laser engraving, 3D printing, etc. etc. So yeah, it's also for you very beneficial if you subscribe to the channel, and then you will be notified every time I make a new video. And well, the last thing, if you really learned something and you are going to make very nice engravings now because of what you have seen in this video, please buy me a coffee. It really helps the channel, and I'm a big coffee drinker. I really love my coffee. So you can really help me out by buying me a coffee. The link is in the description down below, and it works via PayPal. So yeah, you can use PayPal to buy me that coffee. Thanks for watching. I will see you next time. Bye bye.